Hey everybody, we got the study guide for test 4, which is going to be this Friday, 10/21/16, this Friday. And so here's our study guide. I'm going to go ahead and go through the problems with you, but make sure you already have these problems done or you're just checking yourself now, because if you don't know how to do this on the test tomorrow, then it's going to be on you. So it shouldn't be that bad of a test grade. It shouldn't be that bad of a test. So I'm going to label this study guide for test 4. Study guide. And again, that's going to be on February. That test is going to be on February 10th, 21/16. So this upcoming Friday. So let's go and start off with the first one. And both of these say to graph. 1 and 2 say to graph. So we're starting off with the function here. And so 6 to the x, f of x equals 6 to the x power, is that exponential or is that a log function? It's exponential. It's an exponential function. Okay, so that means here we're going to do a table. And again, with these, you have to do a table. But what x values do we use every single time? -3, -2, -1, 0, 1, 2, and 3. Every single time. So you shouldn't even have to ask, Mr. Hall, are you sure that's every time? Every time. So we go and substitute the values in. And then we work them out. And we said when it comes to a negative exponent, in order to make it positive, we have to flip the number. Flip the base number here. So that means that's 1 over 6 cubed. That's 1 over 6 squared. And that's just 1 over 6 here. Okay? And the rest of it we should be able to do without a calculator, without needing a calculator. So we know this is 1, we know this is 6, we know this is 36. And then what is 36 times 6, or 6 cubed? Everybody should get 216. Okay, and then the other ones here, that's 1 over 216. This is 1 over 36. And then that's still 1 over 6 there. So now we just need to make sure we get a decimal answer, and let me go get my calculator. Oh, Lord. Here's my calculator. Whew. So 1 divided by 216. So we get approximately about 0.005, because that 4 rounds up to a 5 because of the 6 behind it. 1 divided by 36, it gives us 0.028 because that 7 behind the 7 makes it go up to 8. And then 1 divided by 6, that's about 1.6. Oh, sorry, my fault. It's 0.167. Because again, the 6 behind the 6 gives you a 7. Rounds up to a 7. Alright, so now the only thing is, go ahead and graph them out. And we know the exponential function looks something like this with the asymptote. So make sure you have the asymptote. And we'll be looking for that on the test. So when we do it, and do 1, 2, and 3. -1, -2, and -3. Let's move it over some. Okay. And then going up, you can go by 10s, you can go by 20s. I'm going to go by 20s because I just want to do that. That's not going to work out. I'm not going to have enough space. Oh, Lord. Let's do 50s then. So again, it's up to you, whatever you want to do, as long as you label and it doesn't like jump weirdly, as long as it makes sense. So now I've got up to 250 up there. I went by 50s. Alright, so when we graph them out, we need to make sure we graph it correctly, and just make sure again, when it comes to these parts, that 0.005 and a 0.028, just make sure it's low, but it's going up each point. So for -3, we say it's about right here. Then -2 is going to be a little bit higher. -1's a little bit higher. At 0, it's at 1, so it's a little bit higher. And then for 1, it's at 6, so it's a little bit higher. For 2, it's at 36, so it's a little bit higher. Not 50 yet. And then at 3, it's at 216, so that's way up here. Somewhere between that. Alright, so we just did the ordered pairs there. X and Y, X and Y. Alright, so let's go ahead and graph it out. Alright, so we have our points, and make sure the points are visible. So whenever I have you graph it out, make sure it's visible. But then also make sure you have your asymptote. Asymptote can be the difference between getting it right or wrong. And it should be right on the x-axis, not above the x-axis, but right on the x-axis. Okay, and that's it. That's all you had to do for number 1. Okay, so then let's go to number 2, and that's graphing the log function there. So let's graph our log function out here. And again, the great thing about videos is if I'm going too fast, you can slow it down or repeat a section on it, and it's okay, or stop it so you can write it down and then keep listening. It's up to you. Alright, so here again, with our log, we need to make sure we change that to exponential. So we need to do our swoosh. So if we need to, we can go ahead and change this as y equals instead of g of x. Same difference. We're going to swoosh it. Make it exponential. So we get 6 to the y equals x. And then here, remember we said before that we're moving it around, or it flips the whole chart around. I said it was an inverse, so here it flipped the x and the y's around. So the first one was exponential, and it flipped it one way, and we had our x's, and we had to substitute to find our y's. And this time we're going to have our y's, we're going to find our x's. And it should be the same thing we just did, simply because it's the same numbers. So hopefully you're not doing too much work on this one. It's the same numbers. So -3, -2, -1, 0, 1, 2, and 3. Again, for log, your y values are these every time. And then your x values are here. Just fill all those numbers in. And again, we know we're doing 1 over 6 cubed, 1 over 6 squared, 1 over 6, and then 1, and then 6, and then 36, and then 216. And again, here, we know that was like 0.005. Here, I think it was like 0.02? Yeah, 0.028, and this one was 0.167. Alright, so in other words, we just took the table we had a few minutes ago, and we just flipped it. What the original x's were, flipped to the y, and what the original y's were, flipped to the x's. So we just flipped the table around to get you the log function. Okay, so now let's go ahead and graph it out. There we go. Okay. Let's do it about right here. So we have 1, 2, 3. We have -1, -2, -3. And again, I'm going to go by 50s. Going to go by 50s. It's up to you again, whatever you want to go by, and it's going to be okay. It will be okay. Alright, so let's go ahead and plot these points out. So, -3, sorry, 0.005 and -3, 0.028 and -2, 0.167 and -1. So a little bit. So in other words, again, each one of these is moving over a little bit each time. Then for 1, we're at 0, so moving over a little bit more. For 6, we're at +1, so moving over a little bit again, moving up to 1. 36 is at 2, so closer to 50. And then for 216 is way down here, and we're going to move that all the way up to number 3. So we're plotting those points there, and then we're going to go ahead and connect them. And again, we have our log function, a log graph, so it should be something like that. Not exactly, but something like that. It's okay. It's something like that. It'll be all right. All right. So this other last thing is making sure we have our asymptote there. So make sure the asymptote is there for that one also. All right, and then we're done. That's graphing out number 2. All right, so then we're going to move on to the next part on the next video.